Hi, this is Professor Muldrow, and I'm going to show you how to download and then use the MARS tool for writing code in MIPS assembler. To get the MARS tool, I've created a, under the modules in CS51 resources, I've created a link to the website where you can download MARS. And here it is. Now, you click on the download button. To download MARS, you click here. MARS is just a Java applet. All you have to do is download it. There's not even any install involved. However, since it's a Java applet, you also need to have the Java development kit downloaded as well. So that's this button down here where you do download Java. So if you download MARS and it's not working, you may need to upgrade your version of Java. If you click on that website, this is what you get. It's a standard platform download. Okay, well, once you download it, it looks like this. This is what MARS looks like when you open it up. Now, I'll write a small program for you following the PowerPoint slides. Make this a little bigger. Now we're going to make a brand new file. It's called mips1.asm. By default, any MIPS file that you create is going to have a .asm extension on it for assembler. I'm going to save this with a different name, and I already have like a MARS folder on my USB drive, so I will just call it, example.asm. There. Now, the homework problem you're going to work on involves an array. Here's how you create an array in MIPS. Alright, so first you type .data. That tells the assembler that you're allocating memory for a certain purpose. And then we're going to call this array A, do a colon, then you type dot space. As you can see, when you type these things in, you get these little boxes that pop up that tells you what it's for. It says reserve the next specified number of bytes in the data segment. Okay, we'll finish the word space, and we're going to say 24. We're going to have an array that's 6 elements long. 6 elements, 4 bytes for each element, so 6 times 4 is 24. Okay, now the actual MIPS code that you're going to run is in, you type .text to indicate that's the MIPS code you're going to be running. Okay, well now what we're going to do is we're going to load constant numbers into registers. Now we're not putting anything into the array yet. So I have li t0, 1, li $t0, 2. We'll just keep going. Whoops, I don't want T0s there. I want 1, 2, 3. That's better. And then li $T4, li $T5. Okay, I changed my values here. 5 there, and a 6 there. Okay. And then we're going to, okay, whenever you use a hashtag symbol in MARS, that's a comment. So we're going to put the starting address of the array, or of array A, in the S0 register. Remember, the T registers in MIPS are temporary values. You can use those as you want. S registers are for things more permanent. Well, they're for variables that hold values longer, and also to put array addresses into. Okay, now we're going to store elements. We're going to use the values in those T registers to put data into the array. So that's where store words come in. So it's T0, and then we're going to say 0, not O, 0, $S0. Remember how store word works? That's the one that's weird because the source comes first. We're going to take what's in T0, which is a 1, and store it into the opening address of the array. So that's what the 0 is here for. This is your offset. To keep going with this, we'll say $T1 for $S0. So this stores what's in T1 into the second element of the array, which is 4 addresses down from where the first one is. Okay, and then we'll just keep going. Okay, so now everything is in the array. And we'll see what this part looks like in just a minute once I assemble this. Okay, now we're going to, so basically for all of these, well, no, let's go down here. Let's do this now. Okay, so now we will assume here, I'm going to put some more comments. We'll assume that X gets $S1 and Y gets $S2. All right, so now if I want to code the MIPS code for, say, X equals A3, here's how it's going to work. Basically, I'm taking something directly out of an array and putting it into a variable. So all I need is a load word. Since the array's on the right side, got to be a load word. So $S1, and let's see, take the index of the array, that's 3, and multiply by 4, that gives me a 12. And the start of the array is at S0. So take the address of the array, add 12, since it's A bracket 3, and you're going to take what's in that array and put it into S1. So there is how you do a load word. Now, I'm going to say now, let's see, we got another one here. We got Y is equal to X plus A bracket 4. Okay. We're still going to use a load word, but now we're doing a math operation. So take care of this first. Now, even though, I've got X has a value right now, it's in S1, but we want to start from scratch. So let's assume we're doing everything from scratch here. So here's A bracket 4. So let's take care of that first. So that's load word, $. Now, since we're loading into the array, but we have a math operation, we're not done with this yet. So now you can pick any T register you want. In the slides, I picked T5, but it doesn't really matter. Now that the T registers have already put stuff in the array, we can use them again. So you can pick any one you want. I'll take T0. And let's see, this would be now, let's see, take 4, multiply it by 4, that's a 16. So $S0. So that gets what's in A bracket 4, third element of the array, fourth element of the array, no, actually fifth element of the array into T0. And now we're going to do an add. Now remember, Y is our destination, and Y gets S2. So I'll say $S2. X is the first source, that's $S1. And then you're adding what's in A4, so that's $T0. Okay. And then finally, you're going to have bracket, let's see, A bracket 1 is equal to X plus A bracket 2. Okay, now you've got an array on the left and the right, so you're going to do a load word to take care of the right-hand side, but then you're going to do a store word to put it in the array on the left-hand side. So do the load word first. So load word, once again, we'll use a temporary register. I'll use T1 this time just because I feel like it. Take the 2 in the brackets and multiply it by 4. That's an 8. And we got $S0. Okay. Now we're going to do some addition here. So we're going to take that and add it to what X is. So that'll be an add. So let's add, and we'll just put it back into T0. It doesn't really matter. Well, we can put it in a different, we'll put it in T2. Okay, let's do that. Although you can use any T register you want. You can use T1 again if you want at this point. T2, it doesn't matter. Okay, so let's see. Then we're doing S1, that's X, and then we are adding what came out of the array. That's A bracket 2, but that's stored in T1, so I'll say $T1. Okay, now that we've got the addition done and the result of the addition's in T2, now we have to store that in S1. So here's your store word. Stored in A bracket 1. Well, the value you want to store is in T2, so T2 has to come first. And now you figure out where to go in the array. Well, let's see. The index is a 1. Multiply it by 4. That's a 4. And you say $S0. And there you go. So there you have your instructions all typed in. Now, first I'm going to save this thing. I'll go up here to File and do a save. Save that file. Now, before you can run it, you must assemble it. And to assemble a program, in MIPS, you have this button right here. I call it the tool time button because it's got a wrench and it's got a screwdriver on it. So this is the button you click to assemble. And when you do, in fact, I'll full size this now. Let me full size the code. There. Move myself down here. Okay, when your code assembles correctly, first you get down here in the log, it says operation completed successfully. So you've successfully assembled this. Now it's time to run it. If you click on this button right here with just the play button, it'll run the whole program and be done with it. But what I'd recommend is you click this button, the one with a subscript 1. That will single step through the code. So watch this. Here's your code, and you follow the yellow line. Here is your register table, and here, let me stretch this. Here is your memory table where you'll see values of the array end up. So first we're going to load up the T registers. So watch over here in the register table. T0, there's a 1, a 2, follow the green line, 3, 4, 5, 6. And then a S0 will get the starting address of the array. First it goes in there, and now it goes in there. This 268500092. It may be different on your computer, but it should still be fine. Now we're going to store stuff into the memory. Now watch the memory here as I step through these. Store word T0, 0, S0. There, the 1 went there. The 2 went there. The code is the lines in yellow, but the memory being updated is the lines in blue. 4, 5, and there it is. There's the 6. So those 6 values got put into the array. They're still in the registers, but now they've been put into the array in memory right here. And now here's the rest of the code. I'll just step through it. So we load up T0 with what came from there. So T0 gets a 5. If you look at the green line over here. And you're going to load that, and then we add, then we load, and you just keep following. And then there's a store word. See? Let me back that up. Here's a blue button. You can back things up. Okay. So here's my first instruction. Load word T0. Now let me back up one more. You load word S1, 12. So this is where S1X gets its value. So right here you see the S1 got a 4. All right, now you load something into T0 to add. That got the 5. And now you add that, and the result goes in S2. And S2 now gets a 9. And now here is where we put stuff back into the array. You load what was in, let's see, that's 8. That's A bracket 2. So T1 gets the 3. And then you add that to what's in S1. So that goes into T2. T2 now gets a 7. And then that 7 should be stored right here. There, see the 7 went there, and it said store word T2 for S0. So there is your demonstration as to how to use MIPS. If you have any questions, send me an email at kmuldrow@lbcc.edu.